We are here at Trimble's Sunnyvale office. I'm Michael Dix. I forced Eric Krantz, our director of High Precision GNSS, director of engineering for High Precision GNSS,
Yes.
To talk to us about a little bit of Trimble history. You see a range of products before you dating decades back. And we'll just talk about how some of the products were, I guess, created, why they were created, some of the big milestones that were the reasons why some of these products came to be.
So we'll go through. Yeah.
All right, Eric. Well, start us off at this end of the table. We've got some very, very vintage Trimble-looking devices. What do we have?
Yeah, so this is our 4000 series. We started off with a receiver that was made to be mounted in a vehicle, perhaps, or a big ship. It was had 8 channels of GPS only. It could get high precision, but the precision wasn't so great. And then we evolved into the next evolution of the 4000 series, which had 12-pole channels, which was still better than what the satellites could do. So there wasn't so many satellites in space 40 years ago.
Was this a bit more portable? Or?
It was a little bit more portable. They probably backpacked them, but not so many, not so often.
Trusty little
handle
right.
there. So you
looks
could carry
legit.
it around.
Okay.
That's right.
Yeah.
And then we get into the 4400 series, and it is now truly portable. They would stick this in a backpack with a car battery and stick it on an antenna, and you'd backpack it around and measure positions.
Yeah. Talk to me about this. Looks like it's got L1, L2.
Yeah, Trimble's claim to fame. We were dual frequency. We introduced RTK back in this time, which gave high precision. So we were able to get centimeters back then.
Oh, okay.
But you needed dual frequency. It was very important.
And did we also move from static observations to you could actually
rove
around with that? Okay.
Exactly.
All post-processed those at that point? Or?
I think they're still post-processed.
Okay.
Yeah.
Cool. And then what was the jump from this?
Then we went from these big boxy receivers into receivers that were pole mounted, because we figured if you can get out of the backpack and put it on a pole, it's much more user friendly to a surveyor, that was their primary customer.
So these two are combined. So antenna and receiver.
Exactly.
This was the first. That was a pretty big deal.
It was a big deal. Yeah.
Okay. And what was this model?
And then we went from, this was 4800, then we went to a 4600. It was a little bit smaller. Didn't have an integrated radio, a UHF radio, which was needed for corrections. We took that out, so that wasn't in this product, but was in this product.
Okay. Was there something also with the chip you said changed in this one?
Yeah, so we evolved from these big electronics that are all discrete electronics into these application-specific integrated circuits. And so they allowed us to shrink things down. So we call those ASICs.
ASICs, okay. And that allowed the little bit smaller form factor?
That's correct.
What's the blue bonnet?
The blue bonnet is
shower cap.
Yeah, we use that to protect the plastic during shipping. And some customers love it, so they keep it blue.
Yeah, some distributors will leave it on to keep
allow the customer to pull it off.
Yeah. Is it, so maybe a question sometimes comes up, will it affect the transmission? So
fortunately, plastic and it's very thin. Has no impact on the performance. Yeah,
if you like the look.
If you like blue and don't want white, you can keep it on forever.
Yeah. Now this looks a bit different than these, so what's going on with this?
So this receiver was purpose-built for a marine application.
Okay.
And it found a position, but also gave you the ability to transmit signals up to geostationary satellites.
Oh, right. So
for distress, they'd have a position and a message, and they could send it to someone who could bring help if you were in trouble.
Yeah, it looks
so
like
there's those big red buttons in the front.
Would actually send a panic.
Yes, a panic or an SOS, if you will.
The other interesting thing on this, it says ensure power is off before approaching within 0.6 meters. Sounds pretty scary. And then microwave radiation exceeding 50 watts. So did you have to keep your distance?
Yeah, you did. We are talking to geosynchronous satellites. They're 25,000 miles up in space, and you need a high power source to get up there.
Because that was a transmitter.
That was the transmitter. So if you wanted to get your signal to that satellite and then down to someone who could help you, that was the method. And so it required a transmitter that was pretty powerful, and you don't really want to be in the way of it.
Yeah.
So stay back. That's the general rule on big transmitters.
Something on that as well about transmit and receive. Most receivers are just receiving. And so some people think, oh, a GPS satellite is tracking me. But the satellites don't actually know where you're at in terms of the GPS and GLONASS and all that stuff. So
not the satellite itself. Nothing goes back. It's all one way. It's all broadcast.
Yeah.
So that's right. That's a misconception.
This looks very, very different as well. Unique.
Yeah, so
product.
some of our corrections, in order to get high precision positions, we need correction sources. So this one uses one that comes from a satellite called Beacon, and it was made to wear on a belt, and it got the nickname of Bob because it was a beacon that you wore on your belt.
Beacon on a belt.
So it was purpose-built
Infamous Bob.
to get a correction source that was primarily used by GIS users. It opened up their world from 5 meters of accuracy down to less than a meter. So that really helped them identify assets in the field.
So that was probably another evolution for Trimble of finding other industries that needed high precision mapping.
Yes.
And you could see that was our entry into the GIS market.
Correct.
Along with many other products, but
yeah, that's one of them.
That's certainly a recognizable one. So
that's right.
Okay.
And then we move into another transmitter. This transmitter was for UHF signals. Again, its primary purpose is to transmit the RTK corrections to roving units.
Okay.
So that's its purpose. And this has 35 watts of power, RF power, so it can go 12, 15 miles to the rover.
Wow.
So you can cover a lot of ground. But it gets very hot, so you end up with these fins that are
these are kind of iconic looks for
the... So the Trim Mark III is its trade name, and the fins are its recognizable feature to dissipate the heat. That was.
Now we're moving into, and even these still out, I think sometimes in the field we're seeing some of these still cranking away. What are we looking at with these?
So we have the 5000 series. We made this big evolutionary step from 4000, which are all these, to 5000, which are these couple of series here. We have a base station, the 5700, and the 5800 was the rover.
This would actually kind of be with that, maybe with the radio, and then
Zephyr would go with the base station. The rover would be on the pole. These were GPS only, so just L1, L2.
Okay.
That's all they could do. The evolution between yellow and gray was adding second constellation. So these had GLONASS. And so they became, from GPS, they evolved to GNSS. So that was their evolution.
That was a big step.
That's a big step. Now we have 2 constellations. You can get better, more satellites that could be looked at, and so therefore a better position.
So were you saying not just getting a position where you couldn't get GPS only, but was it actually more accurate as well? Okay.
Yeah, because you had more satellites. More satellites make
both availability,
more redundancy,
position, and redundancy. Okay, better.
All those things.
Okay, so that was huge. This also you pulled out. It looks like a 3D printed.
Looks like a 3D printed from 20 years ago. So that was one of our early prototypes of the R8 and 5800. And back in the day, you could only print half at a time, so we glued it together, which is interesting. And the resolution wasn't nearly as good, so we ended up with these scallops, and it was super expensive back then. To
How much did you say it was?
$20,000 it would cost us to print one of these. So we didn't print very often, but we did print occasionally.
Because it was helpful. Even in early days of 3D printing.
Yeah, and you can see now, starting with this R series, you can see that we changed color branding from yellow, purely yellow, into these grays that Geospatial thought was more refined.
Yeah. Okay. So it was a look.
It was a look.
Segment out for surveyors.
Exactly. Another base station, the more modern base stations in the R7 was this SPS 855. That was the workhorse for base stations for probably 10 years. It stayed in the market. It was coupled with Zephyr and pushed out corrections. And in that unit, we added GPS, GLONASS, Galileo came into this unit. And then we get into almost our modern family, which started with the SPS 985, which was purpose-built for construction, this unit. So quite big and robust. It was really made to survive the construction environment. So could almost get run over by something and still survive.
Why does it look like a cyborg situation?
This is what it looks like prior to paint. So we coat the things in nickel to make them more robust in the environment, and then we paint over them.
Looks kind of cool, but probably good that we do the paint on it.
Probably better. And then the R10 has similar electronics. These two are similar in how they function. They're just, this one is rugged and this one is light for the surveyor who has to carry it around all day. It's very important.